Next, I'd like to demonstrate another example of Faraday's law of electromagnetic induction, which is that a changing magnetic field or magnetic flux will create an electric field. Here I have a coil of wire, and I'm going to hook it up directly to the galvanometer in this fashion without a battery or anything else in the circuit. This is essentially the circuit we have here. We have a coil of wire wrapped on a spool, and in this case it's hollow, so that I can then insert the magnet into the center of that. And when we insert the magnet into the center of this coil, the coil will sense a changing magnetic field. It's a magnetic field that wasn't there to start with as we introduced the magnet into the coil. So a changing magnetic field will create an electric field in this coil, which will then drive a current through the galvanometer in much the same way that a battery will drive a current through a circuit. So let's see what happens when I take the magnet and insert it into the coil. Now let's watch what happens when I pull it out. Opposite direction. So an increasing magnetic field will cause an electric field in one direction to drive the current through the circuit in one direction, deflect the needle to the left, and a decreasing magnetic field will do just the opposite. Now I'd like to reverse the magnetic field, and we see in that case it causes an electric field change in the opposite direction. And again, when we reduce the magnetic field, that causes a change, and we see that a changing magnetic field creates an electric field which then drives a current through the circuit.